This lecture will explain the rule of OR elimination. So, OR elimination we use when we're starting with some disjunction, and where each of the disjuncts leads to some goal. They each need to lead to the same goal through a series of steps. And if they do, then we're entitled to derive that goal by the rule of OR elimination. And we will justify it by the line that contains the disjunction, the line that contains the goal that is derived from the first of the disjuncts, and the line that contains the goal that was derived from the second of the disjuncts. So it's different from the other rules in that you need 3 justifying lines. So you need the line that contains the disjunction, the line that contains the goal the first time, and the line that contains the goal the second time. Let's see how this works in a proof. So suppose we have the argument P or Q, and P leads us to R and S. If P, then R or S. And then if Q, then R and T. And so suppose what we want to derive is R. Okay, so first of all, there's nothing we can do with any of these statements in terms of just taking them apart. We can't take apart disjunctions. We can't take apart those conditionals. So we're going to need to try to get R some other way. And one way that occurs to us is to use OR elimination. So what we're going to do is we're going to assume P, and we want it to lead us to R. I always draw my boxes right away. So this is an assumption for OR elimination. So I like to write why I'm making my assumptions. And then we're going to assume Q, and hopefully it will lead us to R. And then we can derive R by OR elimination. Okay, so let's see how this works. So P will take us, we can get R and S by arrow elimination on lines 2 and 4. Then we can get R by AND elimination on line 5. So this Q will be line 7. And we can also derive, not R and S, R and T from arrow in, arrow elimination on line 3 and 7. And then R by AND elimination on line 8. And then we have the conclusion R by OR elimination on lines 1, 6, and 9. So that's how the rule works.